this polynomial, right? So once again, let me just content covered. We will be covering this part polynomial. First, we will spatial function here. So this will continue into the station part, and then have here Fourier transformation, interpolation, and some statistics tested. So with more details, we will come so in the basic polynomial, have seen from numpy import poly one dimension. Poly, it's not DL, it's a 1D because we are creating one dimensional array. So we are having poly 1D, right? Because we are having only one variable here. You can this 3x square plus 6x plus 8 is just equal variable. What is the dependent variable here? That is x, right? In case we will have x comma y, so we call it two-dimensional polynomial, not the one-dimensional polynomial. So this is importing 1D, poly 1D, and poly 1D is again kind of function, and we will pass the square matrix over here, right? In case I'll pass, but I want to write this this equation as a suppose 7 x raised to power 4 plus 3 x raised to power cube plus let's say 5 x raised to power square, and then let's say this should be 12 and 12x, and finally let's say 7 as a constant value. So how many coefficients we have? 7, 3, 5, 12, 7, right? So I'll write 7, 3, 5, 12, 7. So 5, 12, 7, last three coefficients. Will run this code, you will find 7x raised to power 4 plus 3x to power 3 and 5x square plus 12x. It will be output of the same, right? But what if you want to include more complex number? Let's say the multiplication part of this polynomial, right? So can you see the multiplication complex part of this polynomial? Here we have the multiplication of this put within the multiplication of this equation, right? Though for physical operations these are very tedious tasks, but for computer itself or command based language are very simpler questions, right? Simpler operations, and compiler is performing with section of, right? So this is how you can perform this entire equation, entire value, and all the values are just here, right? Can we have more powerful functions? Let's say I'm going to print, and then I'm going to some another option, p of 2, right? What of, right? And then finally, if I want to print of comma 3, right? Can you see this is just showing comma 3, right? So here is like 7x raised to power 4. This this is entire p is printing the original p value, right? Look at the p value of p. This is the 187, right? How we are getting 187, right? Suppose we want to need 87, and this is uh 23, right? So and this putting polynomial, and are going, let's see, we are having any doubt till here? So what will happen if you will write some p? So it will just give the entire equation value, right? So find, like, so we will put, instead of x we will put 2 here. So in this equation, this entire equation, we will put the value of 2 here, right? So similarly, if you'll pass 3 common 3, we are having x as a 3, right? So x as a 3 in this equation, we will pass the value. Suppose we have the simpler equation, let's say 6, 8, right? So we are getting 20, right? So let me 9 and let me print this. So have the equation on the 6x plus 8 the equation only, right? So according to 6x plus 8 are getting x value, right? So for this, let's say I'm going to take this as a function fx, right? So at the end of this function, inside this function, I'm passing value. So this 2, 6 in plus 8, right? So what is this plus 8? So the 12, and 12 plus 8 is 20, right? So finally we are getting 20 here. Let me put 3 instead of 2 here. So what would be the f3 value for this equation? Put f3 value here. So this f3 will be 6 2 plus 8. So 6 ja 18. So 18 plus 8 is 26. So finally we are, oh sorry, yes, 26. So finally we are getting 26. So this equation is kind of value, this P2 is kind of value putting 2 inside the entire equation value, right? Now, if you want to find out the root of P, right? So how would you write this root of P? If I write P dot R, can you see it's giving minus 6, 1.833. How it is 1.83? So we have equation plus 6x plus 8 is, uh, would you please yourself? So we have minus 8 upon, sir, Aman, would you self? So this is value 2, the 4, and so 4 upon 3, 1.1 minus 3, 1.3. So this is the root of P also, right? If you'll acquire more complex number, let's say I'm running this function. So now this P is something more complex. So we'll have this imaginary coordinates -1 and the, right? So this is the entire equation value, right? Suppose going to print this entire value P, and for this P I'm going to get P poly 1D, and then get this 1 comma 3, right? Is variable equal to quotes y, right? Addition with variable y, print something, then when you see this is the px square plus 6x plus 8 square, right? So now we have p1 is equal to polynomial 1t, and this is the 1y square, and instead of x square we can convert the variable name. Instead of x we can have y also, right? So this is how you can change the variable name, right? Can we have another variable name instead of variable y? Have another name. Yes, we can take t also. Sometimes we need for time, right? This is the time variable, and this time, this is time. Time equation is 1 t square plus 3, right? Plus 3, right? Part of value. Now, suppose we want to perform the integration of polynomial, right? So, how to perform the integration of polynomial? Kind of print and dot t, then k is equal to, right? So, k is indefinite constant, and perform this. Actually, this was x square plus 8, right? Now, go focus on the equation only, like what is first 3x square plus 6x plus 8. So we have x square plus x plus 8, right? So original have mathematics, and we want to perform this integration part, right? Instead of integration of with respect to x only, right? This is fundamental. So how would you perform this integration? Would be x raised to power 4 3x to the power 4 upon 4, right? This will be 6x square upon 2, right? This would be 8x, right? And constant value. Finally, you can see k is equal to 6. This constant is equal to 6. So instead of c, put c. But have seen this value as a 6. This is not this, but we have passed c as a 6 here. So 3x square raised to power 4, and then you simplify the entire equation. You find x cube plus 3x square, x, right? Then have, oh sorry, square. So we have x, have 3, right? Finally, cut from now 3x square. So that finally it will be x square plus 3x square plus 8x, and finally constant term. Finally, so we will have the final integral. Want to perform the differentiation of polynomial. So for the differentiation, we have find function dot t r e r I v, and that. So for the differentiation, give x square plus 6, have x square plus 6x plus 8. Let me differentiate one more time. The 6x, right? This will be 6 only, and this part will be, right, this third term. Alright. So finally 6x plus 6. 6x plus 6 is the derivative part for this entire function. Is this clear to all of you?